Good afternoon, and welcome to Deep Dive on Amazon S3. My name is Matt Sidley, and I'm a product manager here on the S3 team. And I'm joined by Sally Guo, who's a software development engineer, also on the S3 team. Today, our goal is to provide you new insights into how S3 works. We're going to talk about how S3 achieves its availability, its durability, how S3 scales, and how it achieves its performance so that you can take this information and apply it to your own applications to achieve the highest performance you can on S3. We'll also talk about storing your data, what's the right storage class for your application, and then we'll apply what we learned both on performance and cost optimization through our storage and walk through a data lake case study. And then we'll wrap it up with best practices for securing your data. To start, we wanted to share a little bit about how S3 works, as this foundational knowledge we'll use throughout the session. Today, millions of AWS customers store exabytes of data on Amazon S3. Amazon S3 actually contains more than 200 trillion objects and processes, on average, 100 million requests per second. S3 also offers 11 nines of durability, which means your data is stored securely in at least 3 locations before returning a success. So how does all this happen? To a user, this is simply an S3 bucket, which hides all the complexities of S3. Developers treat S3 as a black box, highly available dependency. So the question is how do we go from the messy reality of a distributed system, where failures are the norm and each component has different availability rates, to something that customers can rely on? And it all starts at the AWS region. AWS has this concept of a region, which is a physical location around the globe where we cluster data centers. Each logical group of data centers is what we call an availability zone. Each AWS region consists of multiple, isolated, and physically separate availability zones within a geographic area. So unlike other cloud providers who might consider a single data center a region, AWS's multiple AZ design for every region has advantages for customers. Each AZ has independent power, cooling, and physical security, and is connected via redundant, ultra-low latency networks. Amazon S3's regional storage classes, such as S3 Intelligent Tiering or S3 Standard, all use this multi-AZ design to store objects across multiple devices and multiple availability zones within a region. Anytime you upload an object, that data is stored automatically across multiple availability zones before returning that success, so you know when you upload that data is stored securely and safely in multiple AZs. All of these underlying infrastructure is how S3 achieves its 11 nines of durability for data and high availability for your data. However, we know that when we're talking about availability, you're only as good as your ability to monitor yourself. And so to achieve this high availability and durability, Amazon S3 has continuous monitoring, canaries, and a whole bunch of other stuff that allows us not to measure just the average, but also the distribution of failure rates and repair rates. And we put all of this into a model that we track to measure availability and durability. The example on the slide shows what this might look like for disks. But in addition to monitoring failure rates, we also monitor repair rates, and again, we factor all this into our availability and durability models. So with 11 nines of durability and multi-AZ resiliency and high availability, most customers build applications that use a single AWS region. However, there are some customers who choose to build applications that span across multiple regions. And there's a few reasons that they might do so. Perhaps they need to demonstrate that ability to be able to operate across multiple regions for compliance. Or maybe you want to increase the application availability to tolerate any connectivity issues to a bucket within an AWS region. Or you might have global users around the world, and you want to reduce that latency of requests, and so you might store multiple copies of data in multiple regions across AWS's global infrastructure. And so to help customers that do need to build multi-region applications, we launched multi-region access points this past September. Multi-region access points provides a single endpoint that you can that your application can talk to, and store multiple buckets in multiple regions around the globe. So when you do use multi-region access points, you can accelerate performance by up to 60% for when you're storing data across multiple buckets around the globe. Multi-region access points uses AWS Global Accelerator, which takes into factors like network congestion and the location of the requesting application to dynamically route requests to the lowest latency copy of your data. This automatic routing allows you to take advantage of AWS's global infrastructure while maintaining a simple application architecture by talking to a single endpoint. Multi-region access points use that same flexible replication rules that you largely know today with S3 cross-region replication. You can choose things like which objects to replicate, to which destinations, or how much network bandwidth to use. Cross-region replication cross-region replication rules offer this flexibility, but with MRAP you can also use the same flexible replication rules, and you can actually set them up directly in the MRAP. So, for example, if you're already using cross-region replication today, you can simply add a multi-region access point in front of your application, and it will automatically route requests. Or if you're building a new multi-region application, you can set up replication rules within the multi-region access point. When you configure multi-region access points, you can also monitor and use metrics. And we use metrics all the time in S3, as I talked about briefly earlier. And so we provide some of these same metrics to customers to monitor their multi-region applications. You can measure things like replication latency, the bytes pending replications, or the number of objects that still need to be replicated. All right, so let's switch gears a little bit and talk a little bit about S3 performance and how S3 scales. And to start, it's really important to go back to this 10,000-foot view of S3, because this is where kind of all the magic happens. S3's infrastructure is a very large distributed service, and it's first important to look at the mental model for how to interact with S3, because it's different than how you might interact with other AWS storage services or a set of on-premise file servers. And as I mentioned, when thinking about Amazon S3, it's important to think about it as a distributed service that's accessible across a wide pool of endpoints. Within a region, you should spread your accesses widely across these endpoints. And that's if you're downloading a large object from a single EC2 instance, or if you're scanning petabytes of data in your S3 data lake from a large EMR cluster. Using parallelism across these endpoints lets you benefit of the scale of S3. We have customers that spread their accesses widely and achieve gigabits or even terabits per second when retrieving data from S3. So if there's one takeaway I want to impart during the performance section of this session, is that to take advantage of S3 scale, and when you're thinking about your application, spread those accesses widely or horizontally scale your application to take advantage of S3. In the next few slides, we'll talk about how you can achieve this. When thinking about downloading large objects, it's important to think about the relationship between request size and latency. As everyone here in this room knows or expects, when you download a large, gigabyte-sized object, that's going to take longer than a megabyte-sized object. And so the way to reduce total request latency is to make a number of smaller requests in parallel. So for example, if you're uploading a large object to S3, you should use S3's multi-part upload to upload the object in parts in parallel across multiple connections. Alternatively, if you're downloading a large object, you should use byte range fetches in parallel over multiple connections. The SDKs will actually do this work for you automatically. But if you're choosing to build the logic yourself, we typically recommend anywhere from 8 to 16 megabyte request sizes. So the past slide, we talked a lot about single large object upload and downloads. However, there's many applications that perform activities like MapReduce or ETL, where you're accessing thousands or even millions of objects in a very short period of time. But the same principles apply here, and you want to take advantage of S3's scale by spreading your request load across the object key namespace. Within a bucket, an application can achieve 3,500 puts or 5,500 GET requests per second per prefix. There's no limit to the number of prefixes that you can create in a bucket. So for example, if you create 10 prefixes in your bucket and spread your accesses widely across those 10 prefixes, you could achieve 55,000 read requests per second. The key here is to spread your request load across the object key namespace to achieve this high level of performance. Another common consideration when building an application that talks to a distributed system like S3 is the consistency model. Last year, we changed our consistency model from one that was eventually consistent to now strongly consistent, in particular, strong read after write consistency. And we're very excited about this, and customers were happy because we were able to do this at no changes in performance, availability, and at no additional cost, and we didn't sacrifice the regional isolation model that S3 has today. So what does this mean for your application? So what this means is that anytime you have a new write request, whether that's a new object upload, you're overwriting existing object, or deleting an object, you can immediately read the results of that new write. We also launched it with strong consistency for list operations. And so this means that any changes or updates to a bucket will be immediately reflected in the list results. All right, let's switch gears a little bit to talking about storing your data and the S3 storage classes. When we talk about storing your data, it all starts with the S3 storage classes. They set the storage characteristics of price, performance, durability, and availability. Amazon S3 has a number of storage classes to choose from for every imaginable use case. Whether you have high-performance applications, archival needs, infrequently accessed data, or data residence requirements, S3 has a storage class that is optimized for your data access, durability, and cost needs. So how do you choose a storage class? That's a very common question we get from customers. It's a depends answer, and it depends on the characteristics of your application. First, and to illustrate that, let's walk through a few examples on how you might pick a storage class. So to start, let's say that you had a streaming application where you're using S3 as your origin and you're distributing to users around the world. The data is frequently accessed and by users around the world. So if you know your data is active and frequently accessed, S3 standard is the best choice. It's designed for 99.99% availability and milliseconds access. All right, maybe you have a different application. Let's say that you have a photo sharing application where you have end users that upload photos to your S3 bucket. But once they're in your S3 bucket, they're infrequently accessed about once per month. So for an application like this, we would recommend using S3 standard IA, which is designed for that infrequently accessed storage saving you 40% on your storage costs compared to S3 standard, but will a retrieval fee when the data is accessed. All right, another use case. Let's say that you have medical records that you've been keeping for long periods of time, or maybe you have news content or media content that you keep around, and it needs to be online because when there's a breaking news story, you need to access that data immediately, but for the most part, it's rarely accessed. So for a use case like this, we would recommend the new S3 Glacier instant retrieval storage class, which is designed for that same milliseconds latency, but for data that's accessed about once a quarter. S3 Glacier instant retrieval is our newest storage class. In fact, we just launched it yesterday. So I wanted to spend a few more moments talking about how we should think about this, or how you should think about this as customers of S3. You know, for a long time, we've heard from customers, or for the past few years, we've heard from customers that they often have this archival data that is rarely accessed, but when they do need it, they need it back quickly. It needs to be effectively in an online archive. And so we created this new storage class called S3 Glacier Instant Retrieval, which is designed for exactly those use cases. It's the lowest storage cost for long-lived data that needs still that millisecond access. It provides the same latency and throughput as S3 standard or S3 standard infrequent access, and is designed for 99.9% availability. It has 11 nines of durability and also stores data across multiple availability zones. S3 Glacier, as I mentioned before, S3 Glacier Instant Retrieval is ideal for those use cases that you need data to be online, but is rarely accessed. However, if you have archives that can be offline, you should also consider one of the other two Glacier storage classes, S3 Glacier Flexible Retrieval or S3 Glacier Deep Archive. They're our lowest storage costs, the lowest cost storage in the S3 portfolio. And they're designed for asynchronous access, which means that you need to wait a little bit before that data is returned. For S3 Glacier Flexible Retrieval, that means data can be returned in as few as a few minutes or a few hours. And S3 Glacier Deep Archive, which data takes 12 to 48 hours, it's kind of the mental model is the next day that you'll get your data back. But in exchange for that, you get the lowest storage cost in the cloud at about $1 per terabyte. All right, let's say that you have a different use case where you have backups that you want to store in S3. If you know that your data is recreatable, you should consider using S3 One Zone IA, which, unlike our regional storage classes, store data in a single AZ. In exchange for that less resiliency, there's a 20% lower cost than compared to the equivalent S3 standard IA. If you have data residency requirements that you need to keep on premises or in a hybrid environment, you should consider using Amazon S3 on Outposts, which delivers object storage to your AWS Outpost environment, and is often used to meet local data processing or data residency needs. Finally, many folks here are running data lakes or thinking about building data lakes. Oftentimes, we see customers that have data lakes have access patterns that are changing or unknown because they have business analysts accessing that data in their data lake from all areas or all business units within an organization. So for data lakes, customers often use Amazon S3 intelligent tiering, where data is automatically optimized based on how the data is being accessed. It goes all the way from frequently accessed data down to archival data. It's one of S3's fastest growing storage classes, and we'll spend in a few moments, we'll spend more time on exactly how it works. But to summarize, Amazon S3 has a number of storage classes to choose from for every imaginable use case, whether you have demanding performance needs, infrequently accessed data, archival needs. S3 has a storage class that is optimized for your data access, durability, and cost needs. So as I mentioned before, S3 intelligent tiering is one of S3's fastest growing storage classes. In fact, customers have saved over $250 million using S3 intelligent tiering, So I thought it was important because we often get customers asking how exactly it works and how do I achieve these cost savings. So how it works is S3 intelligent tiering has five access tiers: a frequent access tier, an infrequent access tier, an archive instant access tier, and then two offline archive access tier and a deep archive access tier. Each of these access tiers reflect the storage classes that we just talked about in terms of price points. But the way S3 intelligent tiering works is it's a storage class, and so you upload data into the storage class or lifecycle data into the storage class, and all data starts in the frequent access tier. S3 intelligent tiering automatically cost optimizes based on how that data is being accessed. And the way it works is that after 30 days of no access, an object would move from the frequent access tier down to the infrequent access tier. And then after additional 60 days of no access, it would move from the infrequent access tier down to the archive access tier for additional 68% cost savings. All three of these online access tiers have the same performance, meaning there's no trade-offs. There's no trade-offs in performance for price, and they all have no retrieval fees when accessing the data. If the data is accessed in one of these three access tiers, it is automatically moved back to the frequent access tier, and the lifecycle starts over again. Additionally, there's the two archive access tiers. These are opt-in, and the reason is because they have different performance. They are all asynchronously accessed, much like the Glacier storage classes. So if you opt into these access tiers, after 90 days of no access, the object would move to the archive access tier, and then after 180 days of no access, to the deep archive access tier, where you get that same about $1 per terabyte per month. All of this is within the S3 intelligent tiering storage class, so that means that you can use this storage class without any changes to your application and no operational overhead. Earlier we talked about monitoring your data and the things that S3 does to monitor its systems. Last year, we launched a feature called S3 Storage Lens, which provides an interactive dashboard to help you monitor what's going on with your S3 storage. We recommend for all customers to go in to your account and turn this on the free tier. It shows you things like how much data is being stored across a number of different usage and activity metrics, 29 in total. But it's really powerful because you can use it at the highest levels of your organization, at the org level, but you can also go down further and aggregate at the account, bucket, or even drill down into the prefix level. As I mentioned before, it's an interactive dashboard, so you can use it in the Amazon S3 console and provides that visualization into how your storage is being used and accessed. So for example, a very common question is, I have a bunch of buckets in my account. I want to understand which bucket is growing most quickly, if I need to take action on that, or if I'm choosing, or if I'm using, or if the objects in that bucket have the right storage class. Or maybe you're looking at to understand which prefixes are being accessed the most. You can use S3 Storage Lens to answer these types of questions. It also provides recommendations. We're talking today a lot about our best practices, about choosing the right storage class. And S3 Storage Lens can help you with our best practices around security, around cost optimization. It's a really neat tool that's helped customers save even more money. All right, so now that we've talked a little bit about the fundamentals of performance earlier and cost optimization in our storage classes in the last section, we're going to put this all together into practice with a case study. I recently worked with a social media platform that was sending over 1 billion events daily into S3 from their social media platform, and they were storing petabytes of data. They ingested events through Amazon Kinesis Data Firehose into their Amazon S3 data lake. Once in S3, they ran hourly EMR jobs to batch, transform, and store the data in Parquet format. They then consumed the data with tools like Amazon Athena. From an S3 point of view, they first loaded their raw data from their Kinesis stream, transformed it, and then made it available to their analysts in their production data lake. They kept this data around for long periods of time, making this historical data as it aged. As we look at this case study, we're going to look at both how they optimize for both performance and cost for each stage. Since this customer was using Amazon Kinesis Data Firehose, they were able to batch the events into larger objects. This helped them save on their request costs because they were making fewer requests. They also used a GUID in their key name structure. This helped them create the many prefixes across their bucket to spread their accesses horizontally and widely across their key namespace, allowing them to achieve very high performance. Finally, they set the default storage class as intelligent tiering. For this customer, they had chosen to keep their data around for long periods of time, and intelligent tiering helped them automatically cost optimize the raw data. Other customers we've worked with have chosen to delete their raw data after a short period of time, making this short-lived data. For these customers, we'd recommend using S3 standard for that short-lived data. Next is the production data lake. This is after the data has been transformed into optimized files like Parquet or ORC format. These files are typically anywhere from a few megabytes to a few hundred megabytes in size. So to optimize performance, we'd recommend using multi-part upload and byte range fetches to parallelize those reads as they're making them. And again, the SDKs can do this for you automatically. We also find that a lot of customers are using S3 intelligent tiering for their production data lake because they have many business analysts across their organization that are accessing the data, making the access patterns very unpredictable. Finally, as data ages and becomes rarely accessed, it turns into historical data. For this customer that we worked with, it was important for them to keep this data around for long periods of time because they later wanted to run machine learning model training on this data. However, it could be offline and in an archive. So for historical data sets like this, we'd recommend using one of the S3 Glacier storage classes or one of the archive tiers in intelligent tiering. And the choice of which S3 storage class to use or which intelligent tiering archive tier to use really depends on what your time to restore requirements are. And so the main difference between Glacier and Glacier Deep Archive is that restore speed. If you can wait a few minutes to a few hours, then you should use S3 Glacier or the S3 Intelligent Tiering archive tier. On the other hand, if you can wait 12 to 48 hours in an offline archive, you should use S3 Glacier Deep Archive or the Deep Archive Access tier, which again stores data at about $1 per terabyte. All right, so now that we've walked through each stage of this data lake workflow, the key takeaway from the case study is to achieve the highest performance and most cost-effective storage. It's really important to optimize for each stage of this data lake workflow. Next, I'm going to hand it off to Sally to share all the features and functionality S3 offers to control access to your data.
Great. Thank you, Matt. Hi, I'm Sally, and I'm here to tell you more about how to secure your data on Amazon S3. At AWS, security is at the core of everything we do. The objects and buckets that you store in S3 are secure by default. We give you granular controls to share that access with others. So for today's talk, I want to first go over two types of policies that you can use for access controls on your bucket: IAM policies and bucket policies. And in addition, here are some features that Amazon S3 offers to help you ensure the security of your data. The first feature I want to highlight here is Amazon S3 Access Points, which gives you simplified access management for shared data sets by dividing access to a bucket by different groups. You can enable block public access on your S3 bucket or at an account level, where public access is not intended. S3 Access Analyzer can help you audit the access controls on your buckets within an AWS account. And you can enable default encryption at a bucket level, so all the objects that you store in that bucket will be encrypted by default. So when you have data in Amazon S3 and have different users using that data, you need a way to give them access. And to do that, you can either define an IAM policy in AWS Identity and Access Management or a bucket policy in Amazon S3. So an IAM policy is a type of access policy that you attach to an IAM user or IAM role. Hence, it is identity-based. And a bucket policy is a type of access policy that you attach to an S3 bucket. Hence, it is resource-based. Both IAM policy and bucket policy follow the JSON format, so we can easily relate one to the other. And let's first go over IAM policy. An IAM policy defines what actions can an IAM user or IAM role perform. It has 3 mandatory elements: effect, action, and resource. So here in this example, this IAM policy allows an IAM user or IAM role to read and write objects to the bucket called sample bucket reinvent. So in this IAM policy, the first element, the effect statement, specifies whether this policy results in a deny or allow. The second element, the action statement, specifies the actions that is being denied or allowed. And the third element, the resource statement, specifies the AWS resource that this policy applies to. So that's all you need for an IAM policy. And again, this IAM policy effectively allows an IAM user or IAM role where this policy is attached to put and get objects to the bucket called sample bucket reinvent. So who gets to apply IAM policies? Well, if you are the IAM administrator for your AWS account, you can define these policies and attach them to IAM users or IAM roles within your account. You can further allow an IAM user to assume an IAM role. With role assumption, the IAM user will inherit the permissions on that IAM role. So instead of using IAM policies, you can also use bucket policies for access control. And this is a resource-based approach because it defines permissions for your S3 bucket. A bucket policy defines who can access my bucket and what actions can those users perform. It is very similar to the IAM policy that follows the JSON format, except it has a fourth mandatory element called the principal statement that specifies who this policy covers. So here in this example, this bucket policy allows AWS account ID 12 once to read and write objects to the bucket called sample bucket reinvent. And the principal statement in a bucket policy can accept a variety of inputs, including AWS account and root user, IAM users, federated users, IAM roles, assume role sessions, AWS service principals, and anonymous users, which is the same as public, but we do not recommend that. And you can further add granularities to your IAM policy or bucket policy with a condition statement. So here in this example, we added a condition that only allows access to the objects that have the reinvent tag on them. We have many more condition keys that you can work with for granular controls. For detailed descriptions, you can go to the AWS documentation page and search for condition keys for Amazon S3, or you can scan that QR code right there. I'll give everyone a second. Awesome. So with that, we'll move on to our second main concept for today. We'll talk about access within your account versus access across accounts. So when you only have IAM users within your AWS account reading or writing data to your S3 buckets, you could either use an IAM policy or a bucket policy to provide that access. But as you expand your use of Amazon S3, sometimes you'll need to share your data with someone from an external account. So if you need to provide cross-account access, you'll need both IAM policy in the account that owns the IAM user and bucket policy in the account that owns the S3 bucket. And this is because S3 buckets are private by default. So in a cross-account write situation, the default behavior is that the writer of the data owns the data. And in this example, we have a user in account A writing data to a bucket in account B. These resulting objects are owned by the object writer, account A. And these objects cannot be read by the bucket owner, account B. And these objects cannot be shared by the bucket owner to a third account, say account C. So S3 resources are private by default, and the writer of the data owns the data. Some customers need to facilitate data exchange and collaboration, but without relinquishing ownership on the objects written to their bucket by others. And for customers using bucket policies for access control, since bucket policies are only applicable to objects owned by the bucket owner, we need a simpler way to simplify object ownership on the objects within a bucket. And until today, bucket owners needing access to objects written to their bucket relies on the applications or users writing those objects to specify what's called an access control list, or ACL, that granted them access. So how can you ensure that you own all the objects in your bucket without relying on the permissions configured by the object creator? And this year at reInvent, we're happy to announce a new Amazon S3 object ownership setting, bucket owner enforced. So when you set object ownership to bucket owner enforced on your S3 bucket, all the objects in that S3 bucket becomes automatically owned by the AWS account that created the bucket. And you can disable access control list, as you can now exclusively rely on IAM policies for access control. An access control list will no longer affect ownership or permissions for your S3 object with this new bucket level setting. So here's what you'll see on the AWS console. For this bucket, once you select bucket owner enforced as the object ownership setting, you as the bucket owner automatically own and have full control over all the objects written to that bucket. And this setting can be applied to any new or existing buckets and can be turned off at any time. As your bucket evolves and becomes a central location for storing shared data sets, your bucket policy can become more complex. You'll probably spend more time auditing and managing it. Amazon S3 access points are a feature that helps you simplify access management for shared data sets. In a nutshell, you divide access to your bucket into separate access points for different groups of users. And here in this example, we divide cross-account users into 3 groups: finance, sales, and dev. And each group reads data from a designated access point that has its own access point policy. With Amazon S3 access points, you effectively decompose one large bucket policy into separate access point policies that you can manage more easily. And within each access point policy, you can further add granularity to that permission. And in addition, you can use access points to restrict access to specific virtual private clouds. Access point aliases are automatically generated for every existing or future access points. They're guaranteed to be unique, but cannot be deleted or edited on an access point. They'll allow you to use this new access point alias generally wherever you use a bucket name or bucket name URI today for data access. So your GET request, your PUT request, or EMR jobs, or Apache Spark jobs can now be pointed to an access point alias. And those services and applications should not know they're now actually talking to an access point alias instead of a bucket name. So when S3 receives these requests to the alias, S3 will route the request to the correct S3 access point and evaluate the access point policy for permissions. So customers can get bucket name level compatibility for data access, but with the features of an S3 access point, all without making any code changes other than swapping that bucket name for the alias name. So with that, we'll move on to our third main concept for today. How do you prevent public access? To guard against accidental public access, Amazon S3 Block Public Access is a feature that applies a blanket protection against accidental public access. And this feature can be set at the bucket level or at the account level. and it provides protection against permissions from access control list, bucket policies, or both. So let's go through an example to see how block public access can help you secure your buckets. So here's an example. In the S3 console, we have a total of 10 buckets. And the access column in the bucket overview page shows me the status of my buckets. So here we have one bucket that has public access, and another bucket that have objects that can be made public. So after I turn on block public access at the account level, all of the buckets are now protected. The two buckets that were previously flagged are now secured and not publicly accessible. So once you turn on block public access at the account level, this setting gives you the overarching protection across all of your buckets and overrides your individual bucket level settings. Customers wanted a way to review their existing permissions and prevent unintentional access permission. So for that, we introduced Access Analyzer for S3. And this feature analyzes permissions for your buckets in an AWS region and provides a simple dashboard that shows you buckets with public access as well as buckets that are shared with external entities. So let's take an example. So here in this example, you can select Access Analyzer for S3 on the left panel. And once you click that, you see a dashboard that contains Access Analyzer findings. Access Analyzer reviews your existing bucket policies, access control list, access point policies, and block public access settings to produce findings. It'll list buckets that have public access on the top panel and buckets that are shared with external accounts on the bottom panel. It'll also tell you the means that granted the access, such as bucket access control list here in this example. Policy validation with Access Analyzer is a new feature that guides you to author and validate secure and functional policies with more than 100 policy checks. You can use these checks while creating new policies or to review your existing policies. So you can use policy validation to confidently check that your policies provide the intended access before they're attached to an IAM principal or an S3 bucket. And this saves you time and improves your security posture while simplifying permissions management at scale. When you share your buckets with external entities, we generally recommend 3 best practices. First, you should run Access Analyzer to understand how your buckets are being shared. Second, you should keep your public buckets within a dedicated AWS account so you can enable block public access at the account level everywhere else. And third, with today's launch, you should enable Amazon S3 object ownership and set that to bucket owner enforced so you can standardize object ownership within your buckets in order to leverage bucket policies. Finally, my favorite topic, let's talk about encryption. Default encryption is a bucket level setting that ensures all the data stored in that bucket is encrypted by default on the server side. So when you enable default encryption on the bucket, all the new objects written to that bucket will be encrypted with the type of encryption key that you configure. So we support 2 types of encryption keys for bucket level default encryption. There's SSE-S3, where S3 creates and manages your encryption keys, and SSE KMS, which is backed by AWS Key Management Service. We recommend encrypting your data for additional levels of protection. Amazon S3 bucket keys is a feature that is most useful for high-volume workloads accessing KMS encrypted objects. It can help you reduce your number of KMS calls, resulting in an improvement in encryption performance and a reduction of KMS costs by up to 99%, depending on your usage pattern. So if you want to use KMS-backed encryption, using bucket keys is highly recommended to reduce your cost of encryption. In addition to encrypting your data, we also recommend performing data integrity validation on the objects that you store in Amazon S3 as needed. However, we understand there are several challenges around this topic. Calculating and comparing checksum on the client side can be slow and inflexible. Third-party tools can be costly, while custom scripts can be hard to manage. and industry regulation may require integrity validation with different checksum algorithms that you may not support. We'll be launching Amazon S3 Accelerated Integrity Checking, a new feature that automatically calculates and verifies checksum during your S3 operations. S3 is able to perform faster integrity checks by up to 92% and at a much lower cost. You can choose from 4 checksum algorithms: SHA-1, SHA-256, CRC32, and CRC32C, and you can access that checksum information at any time. And S3's accelerated integrity checking supports end-to-end integrity verification for all the objects stored in S3, including multi-part uploads and encrypted objects, and it will be available to you at no additional cost. So this feature will be launched soon, so stay tuned for the official announcement. It's still and will always be day one for Amazon S3. And to wrap up, with Amazon S3, you can architect for high resiliency by using multi-region architectures with multi-region access point and replication. You can optimize the way you store your data with different storage classes and by using intelligent tiering. You can monitor and manage your data with native S3 tools and secure your data with IAM policies and bucket policies, and with new launches like Amazon S3 Object Ownership, Policy Validation, and Accelerated Integrity Checking. Thank you. Matt and I will stick around on the side here for any questions that you may have, and we hope you have a great rest of the week at re:Invent.